and we can begin.
Okay, so hi guys, thanks for having us. We're excited to be here. We're just going to be talking about how to make data pipelines with Amazon Web Services. So all three of us are software developers at PowerAdvocate. My name is Claire. I use she, her pronouns. I am a second-year student at Northeastern, majoring in computer science and math. And I'm at PowerAdvocate because I'm on co-op, which is basically a 6-month internship.
Awesome. Thank you, Claire. My name is Mark. I use he, him pronouns. I've been a developer at PowerAdvocate for about 2 years now. And yeah, love my time here.
Hello, I'm Vyshnavi. I use she, her pronouns, and I'm also a developer at PowerAdvocate and have been there for just under a year now.
Awesome. So I am going to just give a quick rundown of what this presentation will look like. We're going to be talking about pipelines, data pipelines, and how we've used the tools that AWS provides to us to enable those pipelines. We're going to try to structure the presentation as kind of a problem and solution in hopes that that is relatable and easy to follow along with. So first, we're going to kind of outline the problem, what inspired us to sink all this effort into the pipelines and get this system up and running. We'll describe the pipelines to you at like a very, very high level at first. We'll then go through each of the different AWS services we've used to enable these pipelines and give some info about each one. And then finally, we'll have an in-depth look at the pipelines as a whole. We'll kind of dive into the details of how they're implemented. And then finally, we'll have a section for Q&A at the end, but there will also be smaller breaks for questions throughout. And if you want to just like jump in and say something, feel free. We're very flexible.
And so what is the problem that we're trying to solve with pipelines? At PowerAdvocate, we have a lot of data from all of our clients stored in different forms, and we store the data in the form that best suited our needs at the time of getting it. So we'll have some data that we store in databases that are designed to be like aggregated or be queried very quickly, such as NoSQL, which you see on the right here, or we have some data that's stored in a relational database like Oracle, which we will talk a little bit more about later, or what relational databases are. But we have data stored in these different databases, which are running on different servers in different locations and are just kind of all over the place. And so as time goes on and as our needs evolved, we started asking questions on how to combine the data that we have because we have so much of it. But because everything was stored in so many different locations, it was hard to find a way to put it all together. And so here's an example that illustrates that. If we have a table in an Oracle database called locations, which just stores addresses and names of addresses and things like that, and we also have a NoSQL database that has a table called events, which has the name of event and other data related to it and the name of the location that it was at, in theory, we should be able to find out where, like the address of the event that I went to. But because this data is stored in 2 different tables in 2 different databases on 2 different servers, we've needed to find a better way to bring those 2 together. And so in this case, a join isn't good enough, but how can we bring them together?
Yeah, so the solution we went with is like a design paradigm that's kind of widely used by many other companies. This isn't something we invented, so I don't want to take credit for it. But the idea is to use something called a data warehouse. Sometimes they're called data lakes as well. But this is really just a massive database that's very good at taking in and exporting large quantities of data. So you could like add 1 million rows to this database at a time if you wanted. It's really not good for querying. So I wouldn't want to like send a request to this database to like sort items and return to me certain results with a filter. That's definitely not what this is built for. It's just built for storing large amounts of data and for moving data in large chunks at a time. So that's what the Redshift is that you see at the top of the diagram on the right. It's an AWS offering, actually, and we store all of our data there. And that has become our kind of like source of truth. Once data makes it into the Redshift database, it's considered like factual and 100% accurate. So then the two green Mario pipes that you see there represent two different pipelines that we might be running. And these are kind of moving our data around for us. Because like Vyshnavi said, the Oracle and MemSQL databases are what our clients are actually reading from, what they're writing to when they make changes. And so that information needs to then get brought to Redshift so that it can be synced with our source of truth. And so it needs to be saved there, it needs to be moved, and then sometimes we'll do a little bit of processing as well. So we might transform or massage the data in some way as we're moving it from one database to another.
Yeah, and so before we go any further, we just want to define some key terms. So in this case, when we talk about a pipeline, you can just think of that as a series of steps that manipulates data. So we can move it around between different databases, we can process it in a certain way, or insert and delete rows, basically anything. And the nice thing about our pipelines is that we can set them to run on a schedule. So everything is done automatically and we don't have to worry about it. And then I also want to clarify that AWS has a service called Data Pipeline. That's not what we're talking about here. We're referring to our own pipelines that we put together with other AWS services.
Sorry, 1 second. One of our slides is like hidden. But just to kind of touch on that, we have a lot of AWS services, and if you want to talk more about those, since the slide is missing.
Yeah, totally. So AWS is a toolbox of cloud computing services. And if you're not familiar with cloud computing, it's basically like renting someone else's computer. And in this case, the computers are all managed by Amazon. So some nice things about it are that we have flexible capacity so that you only pay for the services that you need in the amount that you use. So it's easy to scale up and down if your needs change. And then you also don't have to worry about managing any of the data centers, the physical hardware, the servers themselves, since Amazon takes care of that for you. And then there are a lot of different services, but we're just going to focus on the ones we use for pipelines.
Yeah, so the first one that we use is called Lambda. And Lambdas are serverless functions. And as mentioned, serverless mean, in the case of Lambda, means a way to run code without having to personally manage the server that it runs on. And Lambdas are short running functions. They can at max run up to 15 minutes. So if you need something to run a little bit longer, there's a couple of other AWS services that will handle that for you. And with Lambdas, they can be written in all languages. You'll see here that we have a function written in JavaScript. And so we have an event, and in that event, it contains a greeting and a club, and then we just return them concatenated together, and that's the response. So in the examples below, you'll see a greeting, like hi, and then the club is Mount Holyoke Computer Science Society. And so yeah, it'll spit out hi, Mount Holyoke Computer Science Society. And these functions can be so simple. As you saw, this example is just taking two strings and putting them together. A lot of the code that people can write can be like large, complicated on like application scales, on a scale of like the whole application. But Lambdas are meant to be very short, very simple, and very easy to run. And so we use Lambdas to perform specific pipeline steps. How we do this is we have our pipeline running in AWS, and if we need our pipeline to talk to our own backend, we can use Lambda to trigger calls to our own backend through requests. Yeah, and so what kinds of resources in AWS do you use to connect to Lambda? Claire will be the one to talk about that next.
Yeah, definitely. So the next service we want to talk about is called AWS Step Functions. They're also called state machines. I think the two terms are interchangeable. So these are what you can think of as the pipeline itself, because each state machine is just a series of tasks that AWS executes for you. So you can see an example of one on the right, and these are formatted as JSONs. So JSON stands for JavaScript Object Notation. It's just a data format. And what you need to know about it is that, as we can see below, we have different attributes, which are the strings in blue on the left, and each one has a value. So that's the strings in green on the right, and then on the bottom, the Boolean and the integer. So here we can see that we start at the first state, and that calls a Lambda. Then we move on to the next state that also calls a Lambda, and the second state has a value of, or it has timeout seconds, and the value of that is 600. So if this step doesn't work after 2 minutes, then it will time out and the pipeline will fail. And that can be really useful for us, because if something is wrong and we can't access this Lambda for some reason, we don't want to be trying to get it forever. We'd rather just have it time out so we know that the pipeline fails and we're able to fix whatever the issue was. And so these are just more examples of step functions to show us that we don't necessarily have to run the same steps every time in one linear order. So on the left, we have an example of parallel processing, where we can export all those files at the same time, and then we'll just move on to the next step after we're done with all of them. And on the right, we have some simple decision logic. So basically, we can keep trying something if it doesn't work, and then as soon as it works, we'll move on to the end of the pipeline. And so in order to make our pipelines, we use another AWS service called CloudFormation. And what CloudFormation does is it allows you to create and manage stacks. And a stack is just a collection of resources, which can be a lot of different things, from services we didn't talk about, but for our purposes, our stacks usually have the Lambdas and state machines that we just talked about. They can also have event rules, which Mark will talk about later, and they can also have other stacks inside them. And each stack also has parameters, so those are just keys and values that you can define in order to suit your own purposes. So for example, we can have a key called scheduling enabled that we set to yes or no. And when it's yes, the pipelines will run in a schedule. And when it's no, they won't do that. And this can be really useful, because if we have a pipeline in the production environment, we want that to run on a regular basis. But if we're working with the pipeline and need to make some changes to it in development, we don't necessarily need to refresh any data. We only want to run it when we're testing it. So we can just set that to no. And just as with step functions, we give them to AWS as a JSON. For CloudFormation stacks, we give them to AWS as a template file. So that's either a JSON or a YAML, which is another file format. And This basically just tells AWS all the things that we want to create, and they do that for us. So in this example, for parameters, we have a notifications email, and you can set your own value of that, but there is a default value there. And down below, we have two different resources. So we've got one pipeline and we've got another stack, and that stack has a URL to another template, which describes how to create that stack. And CloudFormation in general is based on the idea of infrastructure as code. So basically, the traditional way to manage cloud infrastructure, where you manually create and provision all the resources you need, that can be time consuming. And there's also the possibility of human error. But if we describe everything that we need in this one file, it becomes much easier to manage.
Thank you. So the next AWS service that we're going to be talking about is DynamoDB. We'll get into a little bit later how this is specifically used in the pipelines, but for now I'm just going to give an overview of the service and kind of what it accomplishes. So first I'd like to talk about the benefits of Dynamo. The reason people really like this service and tends to use it is that AWS provides super high availability for your data, and also allows you to host the data in any region in the world that you want. So if I have a website that's doing really well here in the US and I want to expand overseas somewhere in Europe, I can just spin up another instance of all of my data in a data center in Europe so that people can query and access it much faster without those requests going all the way across the Atlantic Ocean. And AWS will also do dynamic scaling with Dynamo. So if I have one database that's getting a ton of traffic for some reason, like usage of my website is spiking a lot right now, you can configure it so that Amazon or AWS will automatically spin up another instance of the database to kind of allow there to be two places that can now share the load instead of just one. And this really quick scalability is super nice for getting large amounts of data out there and able to be read very quickly. Some of the caveats with DynamoDB, like other databases, it's kind of tailor-made for one role, and you don't want to try to do things that it wasn't designed to do. So Dynamo is a NoSQL database, which is just a way of saying that it is not relational in nature. I have this little diagram on the right to try to explain the difference between a relational and a NoSQL database. You see it says document on the bottom. That's just another way to refer to a NoSQL database. Sometimes they're also called a key value database, and it all essentially means the same thing. But to start with the relational example on top, we'll see that there's two different tables in this database, one for articles and one for comments. And then there's a mapping between the two tables where each of the comments are pointing to an article that those comments were posted on. The way this is usually done is that the article would have some sort of ID, like a unique identifier, and then the comments would have a field associated with them called article ID, which would then point to the article that that comment was posted on. With a NoSQL database, you can't have those sorts of relationships between tables. So all of the information you need has to be stored in one chunk or one item. And you'll see here that we have just a table for articles in our NoSQL database, and that those articles have both the title and the comments associated with them all in one place. Things you don't want to do with DynamoDB, just because it wasn't designed for it, is anything with sorting or filtering. So a lot of database queries that you can write, you have like order by clauses, you have where clauses that do filtering. That's not really something you want to do with Dynamo. It is possible, but you're going to get really slow query times. You're going to have bad performance. And that's because the way DynamoDB was designed, it's truly just for, you know, the ID of a item you want to retrieve, you give it that ID and you get that item back. And other than that, you probably want to look for a different database if you need kind of more support. A little bit more information about Dynamo here to go into some of the AWS terms that they use. They call the places where you store data tables, just like you would in any other place or any other database. So here on the right, we have 3 items from a person table, and we can see that they all look a little bit different. I just used the word item, which you see on the left. That's just an entity inside of a table, one object that you might want to retrieve. And then finally, attributes are the keys that you see in kind of the teal on the left-hand side of these items. And they just represent like a property on each of the items. You'll see that these are written in JSON that we talked about a little earlier in the presentation. You'll notice that a lot of the stuff we do with AWS is configured through JSON, and we're interacting with JSON a lot in our code. And then the final thing I want to point out here is that these 3 people that belong to this person table actually look pretty different once you take a closer look. So the first person up top doesn't have an address associated with them. It's like just last name, first name, and phone number. The other 2 records do have an address field associated with them. But even within that address field, we see subtle differences where the second record has a zip code, but the third record has a postal code. And this is all done to highlight that as long as the items you're storing in the table have a primary key, which is the person ID you see in bold here, you're able to use, or you're able to make the items look however you want. So we can add any arbitrary number of fields to one of these items, and you can really have a very flexible way of storing data. The next AWS service I'm going to be talking about is EventBridge. This is Amazon's implementation of an event bus service or a publish subscribe system. This is, again, similar to we talked about earlier with the data warehouse. This is a design paradigm that's kind of well established. Loads of companies use this design paradigm of an event bus. And this is just Amazon's implementation of that design. This isn't something that Amazon invented and came up with on their own. To talk a little bit about event bus systems in general, the way they work is that anyone can produce an event. An event is just a data object that has some unique identifier, like a string, maybe it's a name. It could be a number representing an ID, and some metadata associated with it. So I can pass along data with these events as well. So that's publishing. Subscribing is you would register with the event service that you want to be notified when a certain event happens. And so when the event service receives an event with that unique name, it will then notify anyone who subscribed that that event took place. A kind of concrete example of this might be in a web application, you have 2 very separate pieces of code that don't really talk to one another in an easy way. And one of those pieces of code might be doing a long running process. Say a file has to be downloaded from your website. So that process gets kicked off. When it finally finishes, that piece of code can send an event out that says, hey, the download has finished. It'll send that event to the event bus. Another completely separate piece of code could have registered to listen on that event. And then when it receives the event that the download has finished, maybe we throw up a pop-up to the client that says like, hey, your download is complete. You can access your file here. So in this way, we can have completely separate parts of our application interacting with one another in kind of an easy to manage way where you're just registering for things you want to be notified about. That's the bulk of what Amazon gives us here as well. They haven't really made any changes to the system. They do have a little bit of their own specific terminology. So you see event producers on the left are just the ones sending out those events. Amazon EventBridge is their name for the event bus itself. The rules you see are what you would actually configure when you were setting this up. They're just like provided as JSON data, the same as a lot of other AWS services. And these are the what is effectively doing the subscribing. So you're saying, when I receive such and such an event, I want to send it out to this consumer or target, which are the final receivers of the events on the right. And so that is all of the AWS services that we wanted to talk about. We're gonna next go into a bit of an in-depth discussion about our pipelines. But before we do, are there any questions about the services themselves? Awesome. All right. So next, we're going to talk a little bit about how we've used these services. We're going to start at kind of a small level. So this first side is just talking about a brokered check, which is kind of one of the steps of our pipeline process. But the example pipeline you see on the left is a state machine, just like Claire talked about. We're kind of going through each one of these steps in a specific order to accomplish moving the data from one place to another. One of the things as we were implementing these pipelines that we came across kind of early on is that there's a lot of repeated steps between different pipelines. And what I mean by that is we could have two completely separate pipelines that are accomplishing different long-term goals, but maybe they both have a similar step in them. Like both of these pipelines rely on like a company table being moved from one database to another database. We don't want to have to move that entire table more often than is strictly necessary. So this brokered check is a way of making sure that we're not repeating work that we don't need to repeat. The key here is that each of these pipelines runs on a schedule. So when it comes time to execute a step, we can see when the last time that step was run and determine if it's necessary to run it again, or if it's been run recently enough, maybe we can just skip over it. So what this looks like is in practice, is that we're executing a single step. Here it's like exporting a table from Oracle. We'll make the brokered check, which involves a Lambda function, the little orange symbol you see there. And what the Lambda will do is it will send a request to a DynamoDB table where we store information about when each of the steps was last run. So it'll look up when was this export from Oracle DB step run most recently. And that could have been run by a completely separate pipeline, but the information still gets written to this DynamoDB table. And then we'll get a response back telling us when it was run. And then it's just a simple check of, was this run more recently or less recently than it was scheduled to run? So if it ran 1 hour ago and it's scheduled to run every 6 hours, we don't need to run it. But if it ran 10 hours ago and it's scheduled to run every 6 hours, we do need to run it this time. And so this allows us to not repeat steps, and it kind of makes our pipelines more efficient. Next, we're going to kind of zoom out a little bit and look at what one of these steps looks like when it's actually executing. So at this point, we've already made the brokered check. We've seen that we need to execute this step again because it hasn't run recently enough. And then when we actually go to execute it, what that usually looks like is it starts with a Lambda function, which is really just a way to kick the whole process off. That Lambda function is just going to send an HTTP request to one of our servers, our backend code. And then our backend code does a lot of the heavy lifting. It's going to be, grabbing the table, exporting it where it needs to go, and doing all of the actual data movement. Finally, once that whole process has finished, which might take, 30 minutes if we're moving a lot of data, we're going to use a callback system to let the pipeline know that we've finished. And the reason we have to use this callback system is, if you remember when we were describing Lambdas earlier, they have to be short-running processes. And there's actually a cap as to how long AWS will let you run a Lambda for. Because we don't want to be running up against that cap, we use the Lambda to very quickly send a request, but then the Lambda gets essentially destroyed and doesn't exist anymore. So we need to notify the pipeline in some way that the process has finished. And so we'll just use a success or fail callback, which is just a URL that points to Amazon and then has a flag that says like, yep, we did what we wanted to, or it says, no, something went wrong, and we need to enter an error state. The thing that is listening for those URLs is the EventBridge service we just talked about. And the way that works is that the URLs kind of replace the event producers here. EventBridge is very flexible. So instead of a piece of code sending an event to EventBridge, we're now using an HTTP request to send an event, but it's the same process. And then finally, we have those rules configured inside of EventBridge that tell us when we receive this callback URL, we want to send some information to this pipeline, telling it to move on to the next step. And then the entire process repeats. So we would move onto another step of the state machine. We would do another brokered check, and then we would use a different Lambda to kick off that step of the process.
And so now tying it back to the problem that we talked about originally, where we have data in 2 different databases on 2 different servers, how can we use pipelines to solve this problem? The first step is that we can use pipelines to export data from both the location and event table on a regular basis, and to make sure that the data is as up to date as we need by using the broker checks that Mark talked about previously. Once we've exported the data, we can import it into our data warehouse and then process the data and then join it together so that we can associate the location of an event with the details of the event itself. And then finally, once all of that data has been processed and put together, we're able to put the data back into a database that's visible to clients. As mentioned towards the beginning of our presentation, our data warehouse or our Redshift database isn't the best for having users query it or have users sort it or things like that. So we would move it to a different database such as SQL, because that's one that's better designed to be able to be visible to clients. And so that's how we use pipelines here at PowerAdvocate. But where does that leave you guys with pipelines? What can you do with them? One common application of them is that you can use pipelines to run processes regularly. So if you wanted to create a web scraping application to figure out when there are openings for events like concert tickets, or more importantly, vaccine appointments, you're able to do that through pipelines. Another example of a real life application is that you can automate text reminders to yourself, because again, we can schedule pipelines to run on a regular basis. And so if there's anything you need to do, like remind yourself to take your vitamins, then you can do that with pipelines as well. And with that, we wanted to open it back up for questions, if anyone has any.
Yep, and questions don't have to be about AWS or pipelines. We're also happy to answer questions about PowerAdvocate or just computer science career things.
I have a question. Where would you actually go to utilize these tools with AWS? Like, is there any way, like a sandbox kind of situation or anything that you can experiment with this and get started and figure it out?
Yeah, for sure. So if you Google like Amazon Web Services, you'll be taken to the Amazon Web Services console, and there you're able to sign up for an account. And with pretty much all services, I believe, there is some degree to which you can use them that qualifies as the free tier. And so you can start playing around with a lot of these and learning how they work, like making Lambda, like calling Lambda functions, building a DynamoDB table, so on and so forth. And you can do that up until a certain point, and you still don't have to pay for anything. It's definitely pretty accessible for just anyone to get started. And it's pretty easy to do a lot of things for free. You might have to be careful with some of the services you use, but you can do it all for free, and that can act as a sandbox.
Perfect, thanks.
And then along those lines, one of the tips that we have with getting started with AWS, because it can get pretty overwhelming once you're able to like get into the console, is picking one and then trying to learn about that. So we talked about a couple of individual ones throughout the presentation, but there's plenty more. But a good way to start is to just pick one of them and learn about that one. And then once you feel comfortable with it, you can move on, but just as a way to dip a toe into the water. Does that answer your question?
Yeah, definitely. If there are no other questions, would it be possible to connect with you on LinkedIn or anything like that for future reference?
Definitely.
Okay, cool. That's really good to know.
And then one last thing before we head out, we actually have a couple of positions available if anyone is interested. Speaking of like LinkedIn.
Yeah, so we have a summer internship and a shadowing program. The summer internship is about 3 months. It's a full-time paid remote position. And the shadowing it lasts for 1 week. Basically, you would be pairing with one of our developers and helping to solve the real problems that we encounter in our work. And also on the last day, you have the option to keep shadowing the developer or to work with someone from our DevOps team. And also, we know that people have different schedules, people might be in different time zones, so you don't have to attend every day, and you also don't have to attend for the full work day. So basically just whatever you have time for. And both of these positions are remote and they're open to students from every year, basically. So if you were a freshman in the spring, that's totally fine.
Is the summer internship, not the shadowing program, the summer internship, is that for this summer? Is there still availability for that program?
It's for this summer. Send in your applications. We'll talk a little bit about this on the next slide, but just to say so now, if you are interested in either of these two positions, please email me, Vyshnavi.Chunduru@PowerAdvocate.com. My email is on the next slide, so that's a place to look for it. But if you email me there with your name, what position you're interested in, your resume if you're interested in applying, or if you just have questions, just be sure to state that and we can send over more information or handle your application from there. And then also please be sure to mention that you were at this event or that you're associated with at Holyoke. But yes, again, to reiterate, this is for this year. So yeah. And then one last position that we have open is for full-timers. If you are graduating this year and you are still looking for a position post-grad, we are hiring for software engineer 1, which is our entry-level software engineering position. That's the position I'm in currently. And so yeah, here's where my email is. If you want information on any of these positions, again, please email me at Vyshnavi.Chunduru@PowerAdvocate.com. I can be sure to put my email in the chat below too, so you guys can easily copy it and stuff. But yeah, email me there with your name, that you're from Mount Holyoke, that you attended this presentation, and what position you're interested in, and resume if applicable.
Thank you so much for that.
Of course. Do any of y'all have any questions or anything else that you would like us to talk about? again, as Claire mentioned, it doesn't just have to be about like AWS. We can just ask us about like PowerAdvocate, software development, anything along those lines.
Liz said thank you that they have an internship for this summer, but they're looking forward to apply for next summer.
Oh, thank you, Liz. Yeah, congratulations.
Congratulations. Where are you working?
I'll be working full-time with Liberty Mutual this summer.
Nice, congrats, that's exciting.
Thank you.
I also have an internship lined up, but I'm really looking forward to the shadowing week. So I might end up slipping in on that.
Yeah, hit me up. Along those lines, we do have like documents for like detailing more about these positions. If you like want us to send them to you to like send out potentially to members of your club, if anyone is still looking for positions or anyone is interested.
Yeah, definitely. If you have those documents, then I can send them out to our CS community and everything and spread them around the entire department.
Awesome. Yeah, we'll definitely get those to you ASAP.
Yeah, definitely. Okay, so I don't think we have any more questions. We had a PowerAdvocate event earlier, or like a couple weeks ago also. So the PowerAdvocate specific questions might have been answered already, but this is very helpful. Thank you so much.
Of course. It was a pleasure.
Yeah, thanks for having us.
Likewise, thank you for having us. And thank you for your time today.